Now let's look at the examples for the rational functions. So here's an example. A company that manufactures computers has established, on the average, a new employee can assemble n components per day after t days of on-the-job training, as given by n of t equals 25t plus 5 over t plus 5, when t is greater than or equal to 0. So the question is, what is n of 5? So that means after 5 days on-the-job training, how many components does a new employee can assemble? Okay, and what does n of t approach as t increases without bound? So in other words, when t is very large enough, what is this n will approach? So that means you need to find the horizontal asymptotes. Okay, so now let's look at the first one. So n of 5. So n of 5 is equal to, just replace t with 5. So this is 25 times 5 plus 5 over 5 plus 5. So this would be 130 over 10. So this is the 13. So that means after 5 days on the job training, on the average, a new employee can assemble 13 components. Second, after a long time on the job training, what does the n approach as t increases? Okay, so that means we need to find the horizontal asymptote. So let's rewrite this one. 25t plus 5 over t plus 5. Horizontal asymptote, that is n because the degree of the numerator is 1, right? Here is 1, power is 1. The denominator is also 1. So the horizontal asymptote is y equals 25 over 1. So it's equal to 25. So that means as a long time on the job training, n will approach 25. In other words, on the average, a new employee can assemble 25 components after very long on the job training. In this example, the rational function is given by x plus 2 over x plus 1. So now we want to find some information about this rational functions. The first one is, what is the x-intercept? X-intercept is the y equals 0, right? So f of x equals 0. So in other words, x plus 2 over x plus 1 equals 0. So the x-intercept will be x plus 2 equals 0, so x equals negative 2, right? Would be the x-intercept. And the y-intercept, which is you set x equals 0, right? Set x equals 0, so you will have y equals f of 0, which is 0 plus 2 over 0 plus 1, which is 2. Right? And the domain, second domain. What is the domain? The domain is all the real numbers except the denominator equals 0, right? So we cannot make the denominator to be 0. So what's the values for the denominator? So it's x plus 1 equals 0. So x equals negative 1. So in other words, x cannot be equal to negative 1. This would be the domain. Right? This would be the domain. So in other words, the domain is all real numbers except x equals -1, or just accept -1, right? That would be the domain. If you use the interval notation, that would be -infinity to -1 union -1 to +infinity. 3. What is the vertical asymptote and what is the horizontal asymptote? The vertical asymptote is the first thing to find the vertical asymptote. We need to simplify this rational function, but actually we don't need to simplify anymore. We cannot simplify it anymore. It's the reduced form already. So the vertical asymptote is the zeros for the denominator, for which is x plus 1 equals 0, so which is x equals -1. So x equals -1 is the vertical asymptote. The horizontal asymptote, since the degree of the top is 1, right? Here is 1, here is also 1. So the degree of the top is equal to the degree of the denominator. So we have the rule says if you have the degree of the top equals the degree of the denominator, then the horizontal asymptote is the quotient of the leading term for the top and the bottom. So here is 1, right? Here is also 1. So which is y equals 1 over 1 equals 1. So y equals 1 is the horizontal asymptote. So from the graph, you will see that this is the horizontal asymptote. This is 1, for example, 2. So this is 1, right? This is 2. So this is 1. And this is -1 is here. -1, -2. So -1 is here. This is -2. So -1 is here. So we don't need any, we don't need to sketch the graph, but we know we can do that, right? Because we also know that x-intercept is what? -2, 0. Y-intercept is 2. So we have the curve, which this is the vertical asymptote. This is the horizontal asymptote. So we must just go through the y-intercept, goes through the x-intercept, right? But actually, we don't need it. We don't require you to sketch the graph. You just know there is the horizontal asymptote and the vertical asymptote. But here I can show you, if you know the x-intercept and y-intercept, you can draw the graph quickly. Okay, so now let's look at the next one. The next one is f of x equals 3x over x minus 2. Again, the first thing, x-intercept, y equals 0, so f of x equals 0. So that means 3x minus over x minus 2 equals 0. So this is the top equals 0, so it's 3x equals 0. Denominator cannot be 0, so x equals 0, right? So this is the x-intercept. 0, 0 is the x-intercept. The y-intercept, which is set x equals 0. So y-intercept is y equals f of 0. So this is 3 times 0. 0 minus 2, so this would be 0. So 0, 0 is also the y-intercept. 2. The domain. The domain is, so here is this is a polynomial over a polynomial. So the domain is the denominator cannot be 0. So this one, which number makes the denominator to be 0? So we set the denominator equals 0, which is x equals 2. So in other words, x cannot be 2. So this would be all real numbers. All real numbers except 2. Right, this is the domain. If you want to use the interval notation, that would be -infinity to 2 union, sorry, not good, union 2 to +infinity. 3. Vertical asymptote. Since this one you cannot simplify anymore, right? This is already the reduced form. There's no common factors for the top to bottom, so the vertical asymptote is the zeros of the denominator. What is the zeros? You set the denominator equals 0, then solve for x. So x equals 2 is the vertical asymptote. Vertical asymptote. The vertical asymptote, let's look at the degree for the top, the degree of the bottom, right? The degree of the top equals 1. The degree of the bottom is also equal to 1. So they have the same degree for the top and the bottom. So the vertical asymptote is y equals the leading coefficient of the top, which is 3. So 3 over the leading coefficient of the denominator equals 1. So here's 1, right? 1 times x equals x. So it's 1. So this would be 3. So if you locate the vertical asymptote and the horizontal asymptote, you will see this is a 1, 2, 3, right? This is 2, so this is a 3. Of course, you have more. Four. This is 4. So this is 3. Okay, and the vertical asymptote is 2. We just calculate 1, 2. So this is the vertical asymptote. This is the vertical asymptote. Right. The x-intercept is here, y-intercept is here. So we have one branch, looks like this one. Right. We have the other one, should be here. Again, the graph for the rational function is not required. You just need to know what is the vertical asymptote and what is the horizontal asymptote from the graph. If the graph is given, can you identify what is the horizontal and the vertical asymptotes? Okay, so now let's look at another example. We want to find the horizontal asymptote and the vertical asymptote. Okay, so the first problem is f of x equals 3x minus 11 over x squared plus 3x minus 4. For this case, we cannot, to find the vertical asymptote, we need to what? Simplify. No, we cannot simplify anymore. So the zeros for the denominator would be the vertical asymptote. So we set the denominator to be 0. So you have x plus 4, x minus 1 equals 0, x equals negative 4, or x equals 1. So you have two vertical asymptotes, negative 4 and 1. The horizontal asymptote, the degree of the top equals 1, the degree of the bottom equals 2. So 1 less than 2. So from the rule, we know that y equals 0 is the horizontal asymptote. The degree of the denominator is greater than the degree of the numerator. The second problem is f of x equals x squared minus 100 over x minus 5, x plus 8. Okay, the vertical asymptote. So the first thing, you cannot simplify anymore, because if you factorize the top, it would be x minus 10 and x plus 10. There's no common factor, right? X minus 5 times x plus 8. There's no common factor. You cannot simplify anymore. So the denominator, zeros for the denominator would be the vertical asymptote. So x minus 5 times x plus 8 equals 0. So x equals 5 and x equals negative 8. So you have two vertical asymptotes, 5 and negative 8. The horizontal asymptotes, okay, the horizontal asymptotes, let's rewrite this one. If you're not very familiar with the expansion, you can expand it, right? Use your calculator. Use your calculator. You can do some very basic calculations. This would be x squared plus 3x minus 40 if you expand it for the denominator. Then you have x squared here and x squared here. Right, so they have the same degree, so the horizontal asymptote y is equal to the leading coefficient for the highest power, which is 1, and then over 1. Here's 1, right? Here's 1 times x squared. 1 times x squared, here 1 times x squared. So it is equal to 1. This is the horizontal asymptote. Third, f of x equals x squared plus 4x over x squared minus 2x minus 24. Okay, to find the horizontal asymptote, the vertical asymptote, the vertical asymptote is the first thing you need to simplify. So let's factorize the top x times x plus 4. The denominator is x minus 6, x plus 4. Okay, so you can see we can cancel out x plus 4. It would be x over x minus 6. So the vertical asymptote is x minus 6 equals 0, which means x equals 6. So this is the vertical asymptote. The horizontal asymptote is, we just go back to look at the original function. Right, so here is 1, the degree is x squared, is 2, the degree of the denominator is also 2. So here is 1, here is 1, leading coefficient is 1, 1. So y equals 1 over 1, which is equal to 1. Number 4, f of x equals x minus 4 over x squared plus 8. So the first thing, we cannot, for the vertical asymptote, we needed to simplify it, but we do the observation, we cannot simplify anymore, right? You cannot factorize the x squared plus 8. So the x squared plus 8 equals 0. So it should be the zeros for the denominator. But we notice that x squared plus 8 is always positive, so it cannot be 0, so there's no solution. So in other words, no solution for this equation. So in other words, there is no vertical asymptote. No vertical asymptote. Okay? The horizontal asymptote. So now let's look at the degree. The degree of the top is 1. The degree of the bottom is 2. So the degree of the top is less than the degree of the bottom. So that means y equals 0 is the horizontal asymptote. Let's look at this example. The financial analysts in a company that manufactures ovens arrived at the following daily cost equation for manufacturing X ovens per day. The equation is given by the c-axis, the total cost, equals x squared plus 4x plus 1,800. The average cost per unit of production at a production level of X ovens per day is C bar, which is C of the total cost, C divided by the X ovens. So to find the C bar, the rational function, C bar. So the C bar is from the formula. This is C, the total cost, over X units. So this would be X squared plus 4X plus 1800 over X. Yeah, this would be ours.